Good morning, everyone. Welcome to the Administering SQL Server 2012 Jump Start. My name is Rich Curry. I am here with Mr. George Squillace. He's got SQL in the name. Good morning, George.
Hey, good morning, Rich.
How about a little bit about yourself, sir?
All righty. Well, I come from New Horizons, Great Lakes, based in Michigan. Been a long-term technology trainer. Been a long-term Microsoft certified trainer. Of the last bunch of years, my focus has solely been on SQL Server, which I like. Rich, can I brag on you a little?
Yeah, go
I
for
want to
it.
brag on you, and well, maybe that's not the right word, but some of you are here for the specific purpose of certifying, preparing to certify, icing off that particular preparation process. One good thing, we've passed all 7 SQL 2012 exams.
Oh, yeah.
And I know you've sat in the exam booth an awful lot of times.
Nowhere near what you have, though, George.
96 times in the exam booth.
Mr. Professional Test Taker right there.
So for
That's
those...
hard to do, let me tell you.
So for those that are in particular interested in that area, you're going to have a good day. A bit of other background too. Now, how about you?
Well, I have been a trainer with Microsoft Technologies for about the last 10 years with New Horizons. And prior to that, spent about 20 years in industry. Have been playing with computers since I was 10 years old, and we're not going to tell you when that started because that would tell you how old I am, and I'm not going to do that. Have been a DBA professionally, a developer, and a bunch of other stuff, and hopefully some of that experience is going to come across and help you folks out this day. So, George, how about it? What are we going to be doing today? You want to give us an overview?
Excellent. I like this product. I just want to go on the record saying I like the product. One of the things that I like about it is that this product is huge. And we have an awful lot to take a look at in terms of administration. So we'll take a look first at how we get the product on a box and some of the installation decisions along the way.
Okay.
Module 2, after we get the product on the box, now what? What are some of the server level, database level settings and things that we do? What are some maintenance tasks that we do? Because the product does need some care and feeding. SQL Server operates in a dynamic environment, and things are always changing, and we need to figure out what's going on, improve performance, troubleshoot. So we'll take a look at some tools in that area.
I'm looking forward to that one because I haven't done a lot of troubleshooting. I just don't tend to have problems.
Oh, there you go. So then we'll take a look at managing data. After that, a module of particular concern, implementing security.
Okay.
So we'll see the various onion layers of security, the moving parts of the security subsystem, and then again, a pet favorite topic of mine, and that is high availability.
Yeah,
so we have
a good one.
We have a lot of high availability options, and you know.
Awesome.
So we're going to take a decent survey of those.
Awesome.
And you will want to have a good overview survey of those before the exam. Alrighty, setting expectations. This particular jump start would serve a number of people. Those that already have some experience with SQL Server, you still have plenty to learn. We'll definitely cover an awful lot of topics. You're going to pick up something. There are those who all of a sudden now sit in front of a SharePoint server or some other box that requires the SQL Server product. We call them an accidental DBA. You're going to find you have lots to gain from this as well.
There are a lot of those out there, too.
Oh, no doubt. I mean, so many Microsoft products now require a SQL Server and other third-party products as well.
Yep.
And after that, those that have a laser focus on passing that 70-462 certification exam.
Absolutely.
Some suggested materials to help you out and to describe the person who will be in the best position to succeed. Got to have basic familiarity with the product. Our session here is designed for those that have at least some exposure to the product and definitely relational database exposure too.
Makes sense.
Also, if you are brand new to Windows and the user interface and things like that, this will be a tougher session. So got to have some Windows Server experience.
Okay.
Book-wise.
Okay, so with the books, we've actually got Microsoft Press, the exam training kit for the 70-462, Administering SQL Server 2012 Databases is a great resource. And additionally, if you like what you're hearing today and you want some more foundation, there is a 5-day Microsoft official curriculum course, the 10775 class. That class is offered by the folks that we train for, so you might actually get a chance to spend 5 whole days with us. That would be New Horizons. If you go to the Microsoft Learning site and search on classes, you'll get more information there as well. So, George, how about that MVA community? We've already been a part of that a little bit, right?
No doubt, no doubt. Big online community.
It is. It is. Lots of folks, lots of things to learn, and you get points. If you log in and use this voucher code, which is admin SQL, not DWSQL. The slide has a little bit of an issue there. So admin SQL is the correct code. Put that in. It expires on November 19th, and you will get 50 MVA points. So, George, you ready to get started here? Should give these folks something to think about for the day?
Let's roll.
All right. So this first module, go at it, bud.
Alrighty. So first module, installation and configuration of SQL Server. We can't get into the really grimy detail of all the decision making that you have to do. So we want to take maybe a treetop or a little higher level look at the major decisions along the way, and in particular, some of the critical decisions along the way. So in addition to installation decisions, we have an I/O bound product.
Okay.
So we have to design storage well.
That makes sense.
There are certain particular errors that a DBA can make in relationship to growth, storage, etc. So we have to lay those out on the table as well.
Absolutely.
And always being security concerned and efficiency concerned, we want to scope the appropriate service accounts for running the SQL Server product.
All right, so let's get into that first topic, installation decisions. George, what do we need to know about installing the product? What are the critical points?
Sure. Well, first off, we have a lot of decisions to make. There's quite a number of wizard steps in installing the product, and it's not that it's hard. It's not hard. As a matter of fact, could you? Yeah, that's fine. It's not that it's hard to install the product, but you just have to know what decisions you have to make. And there are a couple that are very hard to overcome if you don't make the decision right the first time around. And also, should you make certain decisions poorly, you're going to have a poor foundation.
So it's like the old carpenter's rule. Measure twice, cut once.
Exactly.
Cool.
Exactly. Alrighty, so installation decisions. We'll take a look. Yeah, we're good. Let's go on to determine the appropriate hardware. Thank you. All right, so laying out some of the hardware decisions. Should we virtualize or not?
Yeah, that's a question that has been going around with a lot of DBAs for a long time. Virtualization has always been viewed as not really a great choice for SQL Server, but the reality is that in the last several years, virtualization's come a long way. And it has really gotten to the point where virtualization versus hard systems, very little difference. Is that what you see as well, George?
Yeah. Clearly the trend is towards virtualization of SQL Server. Maybe not every single workload. You'll have to carefully consider that. But where it used to be a crime or a sin, that's clearly not the case anymore. Now, for CPU sockets and cores, the balancing act with hardware in general is that you want to make sure the workload can be handled. Whatever workload SQL Server has to do, you got to have the hardware to handle it, but I don't want to give away a lot of money either.
That's true.
This, of course, is one of the reasons that has been moving us in the direction of virtualization. We could use our hardware much better.
Okay.
Memory-wise, a lot of times this is a function of the Windows operating system, especially for the highest editions. So SQL Server is a memory-loving product. It serves query code or answers queries out of memory, so the more memory in general, the better.
Good.
Storage-wise, you have questions there too.
Absolutely.
So for maybe a smaller shop, you might have one SQL Server, a handful of SQL servers. Not going to be worthwhile to have storage area network-oriented storage. You'll have direct attached storage, and you'll have to manage that per server. But for a larger shop, 20, 50, 100 instances, you're not going to manage storage server by server.
No, you're going to have a block of disks that's available to everybody. So,
Yep. Another trend we're seeing is the increasing use of solid state storage. I have a link here where you can take a look at maybe some of the places where that could apply, but it's something that needs to be put on the table, especially for some of the heavier workloads.
absolutely.
And Rich, you pointed out something yesterday while we were just chit-chatting and stuff about solid state storage.
Yeah, one of the things that you do need to kind of be aware of with solid state storage is that it does have a life cycle. With all of the read-write cycles that go on, there is a tendency for it to wear out, so you do need to be aware that solid state, in the case of TempDB, it's a trade-off. You can have some performance advantages from having the speed, but there are also some maintenance issues that you need to deal with to make sure that it doesn't run out and wear out while you're dealing with it. So that's really what's going on in that area right now.
Great. For those that are going to have the very heaviest of workloads, consider a couple of free tools that are unsupported. By the way, did I say free and unsupported?
Yeah, they kind of go together sometimes.
So you're on your own for those. But these, let's say you're considering a workload running on a particular hardware platform. Maybe you can persuade your vendor to drop something off for you to test. Without having to install SQL Server, you can run these particular tools which simulate different kinds of I/O patterns and can tell you if this particular platform is good for the job or not.
Awesome. So what about the operating systems? I mean, is there something that you have to deal with OS selection in there?
Oh yeah.
Really?
Oh yeah.
What might that be, sir?
Yeah. Well, you have to make sure that you have the right Windows operating system for the job as well. There are certain features that are operating system bound. From this slide, I'd like to make a primary point. In general, whatever Windows client you have,
Yep.
or whatever Windows server you have, one way or another, you can get SQL Server on the machine.
So it's really more of a matter of choosing the right OS for the situation that you're in, rather than to support SQL Server.
Yeah.
That's good.
Yeah,
That's
definitely.
good.
All right. Now, an innovation with SQL 2012. I don't know if this is considered earth-shattering by the community or not, but Server Core has been around for a while now,
Yep.
and SQL Server supports Windows Core.
Awesome. That's great.
Funny nickname for Windows Core.
Uh-oh.
Windows without Windows.
Ooh, I like that. I like that.
From a detail standpoint, I would not bother memorizing what the max memory, CPU sockets, what versions of or editions of SQL go on what editions of Windows. Don't bother with all that.
So what you're saying is basically any hardware out there is going to have the ability to run SQL. It's just configuring for what the specific data load is going to be.
Exactly.
Good.
So let's take a look at selecting the appropriate edition of SQL, which in my mind is a particularly important decision.
All right.
It basically goes like this. I'm either budget limited, so I'm going to spend the money that I have, or I'm feature driven and I have to get whatever edition has the features I absolutely need.
Okay.
What would be considered the Cherry edition?
Oh, the Cherry Edition, it's enterprise.
Well, no doubt.
Anytime you've got a full workload and you need to do everything, it's enterprise.
No doubt. So I have a link here for you to take a look at an edition comparison. Often I'll ask myself, well, wait a second, this minute feature, is that supported on this edition or that? I don't remember, and I don't want to remember.
No.
So I have the link here. You'll see there are the principal editions, Enterprise, BI, and Standard. And if you want to download an edition to play with that's time limited, well, I have a link for you there. There's a specialized edition, Web, and I want you to be aware of a couple of other editions that might serve you. For a no-cost edition.
Oh, that would be Express.
Express edition. And you know what? It used to be that the predecessor of Express was fairly minimally capable. Express actually can do a lot.
That's
One
good.
CPU, a gig of RAM, but you can have a 10 gig database, comes with GUI tools, can have reporting services. A lot of goodness, Rich.
Okay, but do I have to go out and get a full license if I'm working on developing something and I'm not ready to roll it out or something like that? Is there an alternative I can use there?
In fact, there is. I have linked here a link to the Microsoft Store where you can get Developer Edition. $60. Okay, it's a few pennies.
$60?
Yeah, a few pennies under $60, but absolutely Enterprise Edition, feature full. One legal restriction, Rich.
What's that?
Of course, there's a legal restriction. You can only have developer connections.
So no production on that one. Very cool. Very cool. So what are these instances all about, George?
Sure. When I am installing SQL Server, I must make a decision at the wizard step that you see here in the screenshot.
Okay.
And that is, do I want to have a default instance or do I want to have a named instance? So there are two aspects here. First, naming and connecting. But the bigger picture here is that I can have more than one instance on a machine. Picture, Rich, that each one has an electric fence around the instance.
So like a boundary.
It's exactly a boundary. So I would have a different SA, a different system administrator for each instance.
Okay.
Okay. Have a different system administrator. I can have different security assignments. I can have different service level agreements, different collations. I've listed a bunch of the reasons on the slide here why I might want to have a separate instance.
So it's more about being able to control how that instance is operating without having to affect other installs that are being used for other purposes.
Precisely.
Cool.
Just a curious fact. No, this isn't important for the test, just curious. Every single edition of SQL Server supports up to 50 instances.
That's a lot. I think that's more than most people are probably going to ever put on a single machine.
Yeah, now you and I both have teenagers, so we know just because you can doesn't mean you should. There
I
you go.
like that, yeah. So one of the things that goes into instances are collations. Can you talk a little bit about that?
Sure. I had one little follow-up thing on instances, and my reigning heavyweight of those instances or those circumstances out in the world that I'm aware of, one of my customers or one of our students, 19 instances in production on one operating system.
That's pushing it.
That seems like that's pushing it to me too.
Absolutely.
Okay, collation. So let me start off with the definition.
Okay.
So a collation is a rule book of text-based sorting and comparison rules. And part of the relevance here is that I must pick a collation. Now, as we were discussing, one thing that's good during installation, the SQL Server installation will look at the language of your underlying operating system and at least grab you by the nose and make a strong suggestion as to what you should pick.
Okay.
There are still two major decisions, as you can see from the screenshot here, whether I use a legacy SQL collation or a Windows collation. Strangely, a SQL collation is the default, but Windows collations are suggested.
So you can use the legacy or you can use the current ones defined in Windows.
Absolutely.
Good. So can you show us a little bit about that, George? Let's go over and take a look maybe.
I would. So first thing up, we know that you have to make a collation decision. And I want to come up with a corny phrase to help everybody grasp something.
Okay.
And the corny phrase is like begets like.
Okay.
So we'll find then, let me flip over to my demonstration environment.
All righty.
All right. When I install my instance,
Yes.
I stepped in a bear trap.
Okay.
A collation was set at the instance, and I'm able to look at this both in the graphical user interface
All right.
and also in code if I want to.
Okay.
Now, one of the impacts of this is that my tempDB database is going to have the same collation as DAD, so to say, and that is not configurable. One other curious thing, I'd like to point out some of the naming conventions just real quick. Notice that this says it has a SQL collation, that's a prefix, as opposed to a Windows collation. And without getting too gory, we see a couple of other sensitivities here. We see case insensitive, but accent sensitive.
So the CI is case insensitive, the AS means accent sensitive.
Now, do you have memorized the list of all the other sensitivities?
No.
I don't either. But
I remember the I and the S for insensitive and sensitive. That's about as far as my memory goes.
Yeah, same here. So
All right.
let's say now I create a new database with the graphical user interface. I, of course, have to refresh. So I did not, as you see in code, specify a particular collation.
So it assigned one for you?
So guess what happened? Like begets like. It's going to have the same collation as dad.
All righty.
And in fact, just so everybody gets to see this, if I wanted to see this in code, well, I have a function that I could use, point to the particular database, and use a function that will return the particular collation of the database that I am currently pointed to.
Okay.
Whoops. All right, next up, do observe that when I create a database, I can specify an override collation. Are your kids just like you?
I hope not.
No, my kids are not just like me. And refreshing my list of databases, I go to my multilingual speak DB, and now, of course, I see the specified collation.
Awesome. So you can change the collation for an individual database if you need it. Do you have finer grain control even?
In fact, I do have finer grain control. And with the code seen here, you'll observe that on a text column by column basis, I can specify the collate clause that will then dictate how text-based comparisons and sorting will work for that particular column.
Awesome.
So following a trail, we now know we have instance collation, we have database collation, and text-based collation.
Okay.
To drill down real quick, I'll go to tables. I see this particular table. I see a column. Let's pick one of these. I'll go to properties, and what do we see? Yep, we see an override collation.
Awesome.
And Rich, you know it goes deeper than that.
Sure it does, because you can actually specify it.
Down to the query level.
Awesome.
So that's what we're going to take a look at next. I'm going to create a table. And if you observe carefully, once again, I'm using per text column collations, one being case insensitive and accent sensitive, and the other being sensitive to both.
Okay, so two different collations, two different columns.
That's right. So notice I'm inserting mixed case data into both of these, which I'll take care of.
All right.
And now, querying the case insensitive data column, I'm now going to query using text data that did not match what was inserted.
Capitals in one,
That's right.
lowercase in the other.
But now when I query that, I actually have a row returned because it is a case-insensitive collation.
Awesome.
Let's see where this goes now when I query the case-sensitive data column with all lowercase data. You can probably figure out the end of this movie and...
yeah, nothing comes back. No matches found.
All right, drum roll, please.
Okay.
So now we see that I can actually override collation behavior on a per query basis, once again using the collate clause. So I'm querying for the presence of all lowercase data against the case-sensitive data column, but I overrode that with a case-insensitive collation.
Very cool.
Okay, there are a couple other things in here we could take a look at, but that's good for now.
All right. So overall, basically, there are some things that you can choose. There are some things that you can't choose. There are other things that you can change if you choose them wrong. So
that's right.
Installation's about trying to get it right the first time, but not being absolutely locked in on everything.
That's right. So certainly with collation, we have some liberty, after the fact.
Yep. Awesome.
That's good.
All right, so then one of the things that we need to take care of also is ensuring that we have all of the storage set up, that we've got somewhere to put our data. Can we talk a little bit more about that?
Let's do that. Good news is, more than ever before in SQL Server, you can set a lot of default locations, as you can see from the screenshot here. And that doesn't mean you can't place files in locations outside of these, but they're just that. They set default. So if I back up data, if I create a new database, I can specify a data and a log file location, things like that.
Okay.
So in this topic, we'll take a look at general file system design principles. We'll also take a look at some advanced database design and the circumstances that may encourage that, and some of the building blocks that go into that.
So what's the first thing that we really need to think about?
Principle number 1.
All right.
Spreading.
Spreading. Don't put all your apples in one basket?
Something like that. So
all right.
Let's take a look at a typical Windows server, a SQL server. It's going to have Windows I/O activity. We'll have data file I/O activity, which is random and also involves reads and writes.
Okay.
And then finally, we have log file activity, which is sequential and write-oriented.
Okay.
One of the biggest I/O taxes is moving that I/O head. So we don't want to move the I/O head, in particular on the log file. And also on the log file, I don't want to have the overhead of RAID parity.
Okay.
So I have here in a diagram a few different file system design suggestions, starting off with a lab machine, which is fictitious. I have everything of importance on one drive letter.
Okay.
Again, just because I can.
Doesn't mean you should.
Doesn't mean I should.
Absolutely.
So then I have a progression of maybe a small, very low workload server up to something that's much more industrial strength.
So what is the most important thing you need to keep in mind when we're talking about setting up these drives? So is there something to worry about as far as keeping data and log files separate or tempDB separate? Or what are the things you need to think about there?
Yeah, like we see on the slide there, you want to separate log files and data file activity. So that's clearly, especially for a heavy workload, one of the most important design considerations.
Cool.
You're still going to have to come up with RAID levels for each of the storage units that you allocate. You have a lot of choices. And some of you are hardware savvy, others are maybe coming along learning your hardware.
Yep.
I have a link here to, well, it calls itself raid.edu. So if you want to learn the difference between RAID 10, RAID 0+1, RAID 6, RAID 5, etc., there's some nice little multimedia graphics. I like to give that out to my students.
Cool. What about separation of data files themselves? Anything that we need to think about there?
In fact, yes. Looking at a more advanced database design, we'll see that this will involve multiple file groups which are supported by at least one file, possibly multiple files.
Okay.
And as you can see from the diagram here, part of the point is positioning space-occupying objects over different file groups.
Okay.
So using the principle of spreading, I now can spread out the I/O and querying activity and the maintenance activity over multiple read-write heads. I have a general rule, though.
What would that be?
General rule is, for every single file that I'm going to add to a database, better be on its own drive letter.
That kind of makes sense, because otherwise, what's the sense in having multiple files?
I'm going to have the same read-write heads fighting for the same data file activity. Now, even though my diagram shows multiple log files, it's only so that you know you can. This is not a recommended procedure. It's only going to be used if the first one fills up.
Yeah, so the only time I've ever really seen that used is to migrate from a transaction log from one drive to another, is really what that helps out with.
Yeah.
So
now I want to spy, before we go to the next slide, I want to spy into one particular circumstance. Notice that I could have, let's say, a table in one file group and a non-clustered index in another file group, but observe the top of the diagram where I could actually have one single table spread out over multiple file groups.
Multiple file groups?
Multiple file groups. Now, the reason that I'm going to go to this design to begin with would be twofold.
Okay.
Performance, meaning more read-write heads involved in reading and writing. That part I already brought out. But maintenance, I have smaller units of maintenance that can be done over, well, smaller units.
Awesome. Awesome. So is there anything else that you would use multiple file groups for, George?
I can back up one file or one file group at a time as well.
Okay, cool.
Yeah, so let's say I had, let's say I had, you know, a multi-terabyte database. I might want to back that up in pieces, maybe one file per day, one file group per day. I'll tell you from experience, though, if you go to that more advanced design, you better model your disaster recovery. But you want to have a military drill where you really know how to do this.
Yep.
Just deviating from the plan here a little bit, I find that every time there's a disaster situation, there's always some X factor, something that wasn't accounted for, something that changed, and it's tough enough to get it right, or tough enough of a situation. You know, by the time you start adding X factors plus other problems, you just want to avoid that.
Yeah, and by the way, we are going to be talking a lot more about that later on today in a module coming up. That would be the one on managing data, so stay tuned for that as well. George, are file groups used at all in partitioning?
They are, and in fact, we'll see from the diagram here, not to go into too much detail, but this shows the primary building blocks that are involved in creating a table that's divided among file groups. So I have to have file groups, we see that in green, and then I have to have a partition function, partition scheme. Finally, I make a table that then leans on all the other dependencies. So again, the purpose is to spread, maybe I have one partition with many gigs of archive data. I'm not going to load data into that partition. I'm not going to change the data in that partition. So I can have that on. Maybe I don't even back that up quite as regularly. And then I have another partition. Maybe that's where I load my regular data into.
Awesome.
I can also have index maintenance performed on a partition by partition basis. So for particularly large tables, this would be a design idea. Now I have a couple of links down there, which for those that are interested in finding out more, very practically applied code and examples of how to load data into a current partition, fold that into an existing partition, make a new one for the next load cycle. I think you'll find that interesting.
Super. So have you got something to show us now on
I do.
Doing some design?
I do.
And some creation here?
Sure. We'll take a look first at creating a database with an advanced design using the graphical user interface. Now, the first thing that we'll observe is that we can create containers of files. Let's say we have an archive file group.
So the containers are the file groups, right?
The containers of objects, or those that hold objects, are file groups. So I can make a couple of file groups, go back to my General tab, and now I can add one or more files and add them to a particular file group. Now, just for typing simplicity in that, I'm going to give fairly non-descriptive names.
Normally you would want to name it something that applies to, that has meaning to you.
Good suggestion. So thanks for letting me off the hook here, Rich.
That's all right. We'll let you get away from it this time.
This time.
And it also helps if you name the database too, huh?
Oh, yeah, you know, wouldn't that help? Fancy DB.
There we go.
Yeah, now we're good. Okay, so this is for row data. Alrighty, now from this point on, this is where I could now create objects. In fact, let me go over here.
So the objects are specified to a particular file group when they're created?
Exactly. This is exactly where I'm headed. Now, we'll find in just a moment. In fact, that's exactly what I'm going to show. Now, for this next part, I want to simulate a more advanced database design, but to do so, I have to make or simulate the creation of lots of drive letters.
So we don't have lots of disk drives, so you're going to create directories that just simulate their existence.
So I just have a virtual machine here. I don't want to make all the storage for all that. That's fine. So next up, you'll observe as I scroll through this, I have multiple data files, multiple file groups in those files, and only to be crazy, not to show necessarily good design, Notice every file can have an individual initial size, max size, growth, all of that. Okay, so let me finish creating this. And refreshing, there is now my advanced design database. And if I go to properties, we'll go to file groups. Notice multiple file groups. If I go to files, all beautiful naming conventions. At least naming conventions. All right.
Awesome.
Now, to finish the drama of the story, notice I can create, actually, I have to go back for just a second. One confusion that I think people often have is confusing the default file group versus the primary. And you're good about pointing out, Rich, that the primary file group holds system objects, system tables, the record keeping of the database and such. And when I only have one file group, the primary, well, guess which one's the default?
Yeah, that's pretty easy. It would be primary.
Exactly. So
what if you don't want everything going into primary, though?
Yeah, a general design rule of thumb is that if I'm going to have even one file group beyond the primary, then set that one as the default file group. But I have an object lesson here. Let's take a look. You know me and my object lessons. So I'm now going to execute a table creation here, and we're going to play investigator and find out where it might exist.
Okay.
So I'll get properties. I'll get properties on this, and I go to storage and observe the file group that it went on is the default file group.
Okay.
This time around, I'm going to designate the particular file group that it goes on, and I have a rule of thumb I tell my students often. SQL Server doesn't do what you want it to do, it does what you tell it to do.
Okay.
And if I told it to go on a particular file group, well, guess what?
It went there.
It did exactly that. So there we go.
Awesome.
All right.
All right, so that was pretty good. But one of the things you mentioned in there is putting objects in the right file group, making sure that they go to where you expect them to. Is there a reason for that? Like maybe we keep running out of space or something?
That's right. So our next topic, we're going to take a look at planning for growth and capacity. We'll see that as a responsibility of the database administrator, there are two particular pitfalls you want to try to avoid when it comes to growth and space. We'll look at those. And as far as major responsibilities, managing space, we'll take a look at how to grow files manually, how to set up auto growth, and some other just general space-related behaviors.
All right. So what are the biggest things that can go wrong?
The good news is there are only really two primary space errors that you can create. I either fill up a file, log file or data file.
Makes sense.
Or I fill up a whole drive letter.
That's a little harder to do.
It has happened, certainly, and in particular, this is even worse for a machine which has more than just a SQL Server role that may mess up other operations, so to say.
So what are the ways that you can kind of take care of making sure that a file doesn't run out of space?
Well, this is a beautiful lead-in actually towards our automation lesson, which will come up later. But if I am aware of a space problem, I can easily solve it before it becomes a problem. Notice, as I'm showing here, I can get properties of a database, pick a particular file, just grow the size.
All right.
As long as I have the space, that's not hard. But you know one of my rules of thumb, if I have to do something once,
you're going to have to do it more than once.
I'm probably going to have to do it again, so I might as well have a code-based version of that. Stay tuned for a version later.
And is there a way where maybe you don't have to intervene all the time?
In fact, let's take a look at auto grow options, and we'll see that on a file-by-file basis, we can set up auto grow. I do want to say we know some DBAs out there that will have strong feelings about whether this might be appropriate or not, and I try to take a balanced approach. What I mean by that is, for a small workload, why put my hand in the metal moving machinery?
Yep.
Just let it auto grow. But if you do, make sure you have an auto grow percentage large enough so that it won't happen frequently, and use percentage. If you're going to buy into auto grow, that would be that should be the way you do it.
Good.
For other workloads, maybe very large workloads, some are very strong-minded about saying this is not a good idea and you should only handle this growth that is via the automation subsystem. Namely because I don't control when SQL Server starts to run out of space and decides, hey, everybody, you have to wait, and now I have to grow.
So would it be safe to say that you manage it manually, but you allow it to grow automatically in cases of emergency?
You know, I'm really tough on blanket statements. I'm going to say generally yes.
All right.
Yeah. I want to deviate and show something, deviate from the quick little plan here. If I go to the model database and quickly get properties and options, we'll review options later on, we'll see a couple of auto categories. You know what? I lost my mind for a second. I was thinking of something else. It's that easy.
It happens.
Never mind. Never mind. Different movie.
One good thing about it, George?
Yeah.
You got the peanut gallery laughing on that one.
Yeah. Totally lost my mind.
All right.
I don't even have my kids here to blame.
All right. Let's go back to this auto growth and growth thing there. Is there a way to monitor?
There is. In fact, there are multiple ways to monitor. It's funny just how many ways you can solve problems with this product. So the first thing you'd have to do is determine when you're going to grow, but be aware of it. So we have agent jobs automation that we can set up. We'll see that later. We can set up alerts. So we have even a self-healing mechanism. I don't want to give away too much of the movie, but we'll see that later.
Save it for later.
All right. We can collect data about storage in the management data warehouse.
Okay.
We're going to look at that later. We have catalog views, dynamic management views, store procedures. Let's just say we have no shortage of ways to determine space.
Awesome. Now, I know databases typically grow forever, right? But, yeah, what happens if somebody comes to you and says, hey, we're running out of space and all that? What do?
We are able to. Let's just say that. You're able to, you're able to attempt to shrink a file if you want to. Now, I've not met one database professional, I don't think ever, that's recommended this. But just know you can shrink or attempt to shrink either database-wide or on the basis of a specific data file. You get more control when you use attempt to shrink a specific data file.
Yeah, rarely, if ever, have I ever seen a database get smaller as it keeps on getting bigger.
And if you have a sense of humor, Rich, isn't it kind of like everything? Everything wants to grow.
Oh, yeah.
The stuff in your closet, the government, companies, everything wants to grow. Databases tend to grow too.
Oh, yeah.
Alrighty.
Absolutely. So how about we go take a look at some of this stuff there, bud? What do you think?
There we go.
All right. So you're going to show us how to make the data files bigger at this point?
That's right. So one of the databases that we have is our little tiny database. I'll get properties on it, go to files. Ooh, it has all of 4 whole megs allocated to it. Let's say we go to 25 whole megs. Let's raise our log file size as well. So as long as I am, well, on top of the situation, I can go ahead and assign new sizes. Everything is just dandy. Now, for a little bit of dramatic value. Hold on.
I don't like drama, George.
All right. We might be in the wrong room then.
Son of a gun. All right, keep going then. Keep going.
Let's go to disk usage.
Okay.
So these are built-in reports to Management Studio. I didn't need to do anything with reporting services, etc. So now we can see the full size of the data files, etc., and other activities down here. I just want to make sure everybody knows about this. I don't really want to go into the detail of the report.
Very cool.
Now, also here, let's just take this down a little bit. And Danny, how visible is this? Is this a little bit small? Okay, I'll try to adjust that for the next time around. Notice using the alter database statement, I'm able to dictate the size of a data file, and I can use that to grow. Looking a little bit closer, you'll see it's about 100 meg. So execute that. Now, to play Doubting Thomas, so to say, let's go to
Doesn't
Files.
exist if you show it, right?
That's right. So we see that we have 100 megs there. And then also, should I go back to my report, you'll see the report also immediately updates. Boom.
Cool.
Okay.
Cool.
So that is our drama value for the moment.
All right. So you had one more topic that we wanted to talk about in here, and that one is going to be service accounts.
That's right. Talk about another area where some people will have some passionate feeling. There's a lot of passionate people in the SQL Server community.
Yeah, you have to be.
Let's take a look at our topics for this section.
All
First
righty.
of all, depending on the services or features that you elect to install, the services often come along with those.
Okay.
And along with that, you have to pick a service account for those services. Strangely, when was the last time a Microsoft product removed a feature in a future version? That doesn't happen too often.
No, that doesn't happen often at all.
There was a button in earlier versions of SQL Server installation where you could say, have every single service use the same user account.
That seems like it would make it a lot easier for the DBA to manage.
It would if that was the choice you actually wanted.
Oh!
So we'll see that there are reasons to pick different service accounts for different services. Let's take a closer look here.
All right. So what are some of the choices that you've got?
Kind of a quick funny story. One of my kids accused me of being or acting like the Godfather, Don Vito Corleone. It was kind of a funny little situation, but I'm going to act like Don Vito, and I'm going to back you into a corner, giving you only one possible decision here.
I hate it when he does this to me.
So here we go. We
Okay.
have two general account decisions. We can either use a built-in account, and you see the laundry list of accounts there.
Absolutely.
Or-
Local service, network service.
Generally speaking, all of those are either going to give too many privileges or too few privileges.
Okay, so that basically rules all of them out.
Thank you very much.
Okay,
so this
next.
means you're going to have a created account, which will be either on the local SQL Server machine in that SAM server security accounts manager,
Yep.
or you're going to use a domain account.
Okay.
And because the service accounts, well, in particular, some may need to crawl out across the network, access other resources, you're going to use a domain account.
Okay, so can I use the same domain account for all of them?
Excellent. Excellent question, that is. We'll just get to the quick part of the story. You're going to use a different account for every single box, meaning if I have 100 database engine instances, it is worth the pain of creating every individual account for every instance of the database engine.
Well, that is the recommendation. That's cool. So what happens if 6 months from now you've got some new stuff and you need to change it?
Excellent. So you'll see from installation or the screenshot here that you can make those choices during installation, but you can use SQL Server Configuration Manager after the fact should you have a design change, a policy change, or something like that. You know the rule of thumb, though, when it comes to changing services.
Tell me, George.
You're not going to use the normal Windows Management Console for managing services. You're going to use SQL Server Configuration Manager.
And why is that?
Let's see. You had a good phrase for that yesterday. What was that? Basically, all the appropriate security gets assigned when you use the SQL Configuration Manager.
And
Was that a
if
good
you
summary?
And if you
Okay.
use the Windows Services applet, it doesn't do what SQL needs it to do. So you end up having to do it manually. So what are some of the rules that go into choosing those service accounts, George?
Yep. The database engine in general is not going to need any fancy privileges, so just create a I call it a dum-dum user, name it appropriately, don't give it any special privileges, domain account.
Okay.
Some of the other services, browser, full text, don't even bother. Just leave the default accounts that are suggested during installation. Now, one of the bigger ones is the agent.
Okay.
The agent has to touch other stuff, so it may have to touch mailboxes, file system shares, other SQL servers, so that you're going to give its own account and assign whatever privileges that account needs. I have a link here, configure Windows service accounts and permissions. If you're willing to throw off the hockey gloves and do a little, get open-minded about what their suggestions are, that might be of interest to you.
Awesome. So can we go take a look at that real quick?
Sure. Last little bit here. We'll see now. And I think I put my taskbar up at the top. Yeah.
Oh, that's
tricky,
cool.
tricky.
I like that. I'll bet most people don't even know you can do that.
So I'm going to go to All Programs, SQL Server 2012. By the way, if I lose my mind and forget that later, don't forget to tell me. I won't be embarrassed. All right, SQL Server Configuration Manager. So general rule of thumb in Windows, select to effect.
That makes sense.
General rule number 2, when in doubt in Windows, right-click.
There you go.
So let's say it was the SQL Server agent service of the marketing instance whose account I would want to change. I'd go to Properties, click on Browse. Now make sure you're going to browse for the account from the appropriate location. You might need to point to an Active Directory domain. And from there, pick the appropriate account. Lo and behold, oh, M for Mia. That's right. Mia as in Miami. So I would have an agent account created for this particular machine. Click on OK. Quick little security note. I can't change the account if I don't know the password.
Awesome.
So that's just a built-in feature. And that's really all we had for this session. So we looked at putting SQL Server on a good footing, looking at the major installation decisions. And now that we'll have SQL Server on a good footing, in the next session, we'll take a look at what changes we might make post-installation, configuration changes and such.
Awesome. So we're going to take a short break now. We'll be back at the top of the hour. Enjoy. See you in a bit. Welcome back to the Administering SQL Server 2012 Jump Start. I'm Rich Curry. We're here with Mr. George Squillace. SQL's in his name. George, what are we going to be talking about now?
A good module here, Rich. We're going to take a look at maintaining instances and databases is the big picture. So we'll take a look at implementing transparent data encryption. Okay. Look at compression options. The SQL Server product, is very highly configurable. We have server level or instance level options. We'll look at some of those, maybe some of those that are particularly good for a heavy workload. We'll also take a look at database options.
Okay.
And explore a particular category of options just to see how to change those and such. And then a topic of interest to you, or really more in your area of expertise, the topic of affinity and parallelism for really those workloads to be carefully controlled.
Okay.
A pet favorite topic of mine, automation. So we'll look at the two major automation aspects. I imagine a lot of the attendees have heard of some of the automation aspects, but there are certain things for exam prep you just have to have down.
Awesome.
And I'll also suggest it very much helps if you have hands-on activity. So.
Sounds good. So let's start in then, shall we?
All right. Security is always a concern, and transparent data encryption obviously is a security technology. So in this topic, we'll see the different kinds of encryption that are out there in the IT industry and what kinds of problems they solve, and then specifically what TDE happens to solve, the problem that it solves. We'll then see how it's applied. That's kind of the big picture look going in here.
Awesome. So what is TDE and why would we use it?
Well, it's a data protection technology, but as far as encryption generally goes, I'm concerned about data while it's in motion, traveling between 2 points, where someone might be able to intercept it, redirect it, blah, 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 or data while it's at rest that someone could steal, alter, something like that.
Oh, that never happens, right?
Never happens.
Yeah.
Oh, my. I wonder...
I've actually been a victim of that. So.
You have? Data theft?
Absolutely. Yep. I had a laptop that had all of our tax information on it stolen from the state, so it happens. But how's TDE going to deal with that?
Yeah, well, to add on to the problem here, now we have terabyte-sized USB drives that I could attach to an instance, easily copy off even some very large backup files, or as we'll see later on, detach some data files, copy them over, slurp them over to my USB external, and then I'm away with super important information.
Oh, absolutely, absolutely.
Now, a concern about any encryption technology is whether or not it involves changing any other practices involving that data.
Okay.
And that's where the T in transparent data encryption comes in. It is just that, transparent. As far as an application is concerned, I don't have to write any special code. I don't write any code. I just access the database as normally, and the files are protected on the file system from theft. And if somebody tries to attach them, copy them somewhere else.
So I don't have to do any special programming on the application side to make to utilize TDE in the environment.
Exactly. No.
That's cool.
Yeah. No special protection.
That's very cool.
No special application treatment. Now, looking at the next slide here, we'll see that transparent data encryption is related to a fairly sophisticated hierarchy of encryption keys that we happen to find in not only Windows, but also in the SQL Server product.
Okay.
So when I install SQL Server, a key is created for the instance that then becomes the parent key of potentially many, many other keys. That's called the service master key.
Okay.
And then we have derived from that a database master key. From that, we'll create certificates for additional encryption. And then finally, when it comes to encrypting a particular database, there is a database encryption key. You will see all this in action with your own two eyes.
Wow.
Nifty.
That sounds like keys upon keys upon keys. You really need a key ring for that, don't you?
You do need a key ring for that. All right, so you saw from the key hierarchy diagram a little bit of an idea of how TDE is applied. I have to create a database master key. And that will be, of course, derived from the service master key. Then a certificate, and then a database encryption key, and then think of being on the end of the runway.
Yeah.
Got to get off in the air, got to hit the throttle, got to turn it on.
So after you got all those keys, you got to turn them on.
Yep. Now, moving to the next area here.
Yeah.
We have concerns.
What kinds of concerns might they be?
There are definitely some potential gotchas with transparent data encryption. You'll see some of the items, the possible areas of concern here. I might not be able to recover a database. I might not be able to move it if I don't have the appropriate keys backed up.
Absolutely.
So I have a couple links here where you can take a look at some of these things. And obviously, with any encryption, there's going to be some performance overhead.
You mean it doesn't happen for free?
No, there's no such thing as a free lunch. We learned that somewhere along the way.
Yeah, no, I know. So what does it cost? Where does that overhead impact us?
It's impact in I/O performance as data is written to and decrypted from the files there. Now, precaution-wise, to avoid gotchas, you'll have to back up all the keys in the hierarchy. So I have an article link here backing up the service master key, and from there you can follow the rest of the article links and look at protecting the other keys.
So when you've got a TDE database, you need to have all those keys available in order to restore it at some point.
Yeah, and I don't have them on a USB drive that's on the top of my display that says I'm the DBA.
Oh, sure. So you don't want to hand the keys to the car to anybody that can grab them. That makes sense. So can we take a look at it, George?
Yeah, let's take a look at it.
All right. So this one we're going to be talking about data encryption and showing how to put that encryption in place.
Excellent.
Now, are we going to be encrypting an entire database on this, George, or just pieces of it?
We encrypt the entire database.
Awesome.
It is entirely protected. So here we go. First, we have to create a database master key. If an instance level key did not already exist, this would then, on the fly, create a service master key in the strange circumstance that it wouldn't already exist.
Okay.
So I can create master key encryption by password. Curiously, this has to adhere, the password I have here has to adhere to Windows password policy. And in addition, for those environments that really need robust encryption, you can have this based on a hardware platform module.
Awesome.
So for now, this will suffice.
So we're creating our service master key, and then from there?
Now creating the master key, and from here, we have to create a certificate derived from the master key.
Okay.
So notice I named the certificate, and then I also give a subject for the certificate. Under the covers, the appropriate public-private key pair, all that's made.
Okay.
I don't have to worry about that part. That part is good. And now let's take a look at a particular database and apply TDE to it. So first, I'm going to go ahead and get pointed to the appropriate database. Nothing real fancy there. And then finally, create database encryption key with an encryption key algorithm. The choice here is AES 256. Yeah, there are a bunch of other choices. This one is the toughest, so
okay.
There are reasons to consider using it. Finally, let's go ahead and set this on.
Uh-oh.
Oh, I didn't change this.
Looks like we tried to encrypt the wrong database on that one. Oh,
yeah.
well.
So that actually is an object lesson, huh?
Yeah.
Alrighty, there we go.
All right. So now we've created the certificate, we've created the database master key, we've turned the encryption on. The database is?
It's encrypted.
Awesome.
Now, honestly, Rich, after I run this code, it feels a little anticlimactic.
It does.
So it's done.
And that means that you don't need to do any programming. So don't let your application guys tell you that you can't do the encryption.
I have a couple recommendations here in my code.
All right.
A follow-up to this would, of course, be to back up all of the keys. There are other references on that. And then additionally, you have to model actually recovering this. Should you have to move it? Should you have to recover from a backup that you want to put on a different machine?
So you want to make sure that once you've put that encryption in place, that you can also get it restored, and you got everything that you need to put it back together.
That's right.
Awesome.
Right,
so let's talk about this next topic then. A little bit on database compression, I think.
Yes.
Things that you can do to make your database more efficient.
Now, just like encryption, there are various compression technologies that the SQL Server product supports. We're going to look at a couple of those in particular, answering the question, what is data compression, and then seeing what kinds of objects can be compressed. And then, of course, we have to focus on how-tos, hands-on, those kinds of procedures.
Yeah, it's always nice to know how to do something that they're capable of doing, so let's take a look. What is data compression after all, George?
Data compression is a trade-off. It's a trade-off by using or observing that you have redundancy in your data, using CPU cycles, which are in abundance, to compress data which may to reduce its size, which may not be in abundance.
Okay.
And we'll see here that there are two different compression options. We have page-by-page or page compression, and row-by-row compression, which we just call row compression. There is backup compression. That's not a particular topic we look at this moment.
So that can be done independently of any data compression, right?
Absolutely. That is an independently used feature.
Cool. What kinds of things get compressed?
Yeah, so there are a lot of objects that are compressible: heaps, clustered tables, different kinds of indexes, single partitions of a partition table. So I've just listed a few of the objects that are compressible.
So basically anything that holds data can potentially be compressed.
Yep, general rule of thumb. Now, if I happen to have file stream objects, I'm going to use a different kind of compression. So just keep that in mind. I'll use something different.
Okay, so how do we go about doing it?
As I talk about how we do it, part of this relates to the kinds of redundant patterns of data that I might have within rows and also from page to page. Doing a little bit of research, you'll find out different kinds of compression apply to different patterns of redundancy, and that's way more detail than you and I have the stamina to talk about right now.
But would it be generally safe to say that if you've got data that repeats or if you've got rows that are missing information, that they might be better subjects for compression than other kinds of data?
Absolutely. So if I have lots of null in a particular table, and if I have a number of fixed length columns, that would generally lend itself towards row by row compression. Other patterns of data redundancy that might be existing across rows within a page, that might be a candidate for page compression. So you see a quick little look at the code that you can use to apply this, which we'll put in practice in just another slide. However, what if I am concerned whether or not compression is going to be worthwhile? You'll see a stored procedure here that you can use to estimate what the potential reduction in storage would be.
So I don't need to take a random guess. I can actually go out and figure out if it makes sense to apply the technology.
Yeah. So
what a great idea.
You like to drive. You told me this, right?
Oh, yeah.
And hearing about the college tour that you did with your son, by the way, that was a heroic effort. That's
2,600 miles in 5 days.
Yeah, that's a lot. So in the same way, well, you were probably out on the road, listening to the radio.
Yep.
Lots of restrictions you hear in the advertisements, right?
Oh, yeah.
Some restrictions apply. Well, let's just say on behalf of page and row compression, lots of restrictions apply.
Yep.
So with that, I have a link to where you can research that more. Let's take a look at the actual code you would use to apply page and row encryption.
Cool.
Compression, sorry.
Yeah, you get hung up on a topic, right? I don't know about you, but language sometimes challenges me.
All right. Barry, how is the text a little better size here?
A little better, yeah.
A little better, okay. So let me just create something to work with here. So I have a database, I'm pointing to it. I'm going to add some tables.
Awesome.
La, 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 la. Now, notice in the first table, brace yourself here, Rich. I have a bunch of fixed length columns.
Yeah,
and I
okay.
did not specify nullability.
So that means there could be missing values.
Could be missing values.
All right.
And we could also combine the fixed length columns into a variable length column using the row compression. So notice I added the with data compression equals row.
So it takes the fixed storage and turns it into basically variable storage. So you're only using what you need.
Exactly.
Awesome.
And then for the next one, we have variable length columns that might potentially have repeated data from row to row.
Okay.
And in this case, we can have page compression. Now, I can also apply these compression features after the fact.
Okay.
But as you can see, I can apply the features either on table creation if I had the insight to know that I would have redundant data patterns, or after the fact.
Awesome. Awesome.
So that's it for that demonstration.
All right, so then let's talk about some of the different options that are available for configuring servers and configuring databases.
Yeah, the SQL Server product is a huge product, and it is a very configurable product. I think of often Microsoft creates products that would serve them, a very, very large enterprise. A very large enterprise needs lots of configurable options. So in this product, we have server or instance level options, database level options. We have to see how to change those, and then we'll take a particular tour through changing some database options.
So are there a lot of different options available at the server level?
Think Home Depot.
Oh, no. No.
Do they have Home Depot
You
everywhere?
can find anything?
Yeah, lots and lots of options. Now, the graphic I have here on my slide is attempting to portray.
I don't see slides.
They're on. I don't know what to do.
Hang on here, everybody, for a second.
We're having a little bit of a tech issue here. So hang on 1 second. I did hit the power button by mistake, and I powered it back up.
Can you just hit presentation
I was in it. I hit it again. And here's hoping that we now have success. Hey, how about that? Thanks to the geeks in the back.
Barry, Danny.
Without them, we wouldn't have a presentation.
All righty. Good
All
job,
right,
guys.
So let's go back to the Home Depot store.
I love this picture. So general rule of thumb, if you don't want somebody to touch something, you put it out of their reach.
Yep.
So server option-wise, we'll find that there are 17 basic options.
Okay.
If we use a particular feature, SP configure, to take a look at those. Now, there are other options that, let's just say, if Microsoft has put them out of our reach by default, you should consider more carefully if you want to use those. And
if they're hidden, then maybe you don't want to go looking.
This reminds me of the registry editor, how there are certain things in Windows and in various Microsoft products you can only configure with the registry. So the point is, it's a feature or something that's out of the reach of a normal, a mere mortal.
Oh, yeah.
The problem is, if you turn those features on or change something with the registry editor, it assumes you're a genius.
You better know what you're doing
And
before you go and do it.
Similarly, with the advanced options, we have 69 total options after you turn the advanced options on. I've listed a couple of these. Obviously, there are a lot. Minimum server memory, max server memory. So if I want to immediately contribute a certain amount of memory from the Windows operating system to SQL Server, I can. And if I want to throttle to make sure I don't exceed a certain amount, I can do that as well.
So to go out and change them, to view them?
Sure. We'll take a look at some of those tools. So I can right-click on the instance, get properties, and there are some options that are accessible there. Keep in mind, not every single option is available in the graphical user interface. This is very consistent with the SQL Server product. Popular options are in the GUI. Anything, generally speaking, you can accomplish in code.
And that code would be
SP configure. So I can turn the advanced, tell me if you think this is circular. I have to turn advanced options on in SP configure in order to access advanced options.
So you configure the options that you can see them, then you configure the options, and then let me guess, you gotta configure them again to shut them off.
Yeah, precisely. Yeah. So in addition to turning a particular feature on, you'll notice there's a follow-up statement, the reconfigure statement. For the longer version of why you need the reconfigure statement, you'll see the link there.
Okay.
Just a notable, there's a popular instance level option you might want to switch. That's authentication mode. More of a security topic, really. But that's something that you cannot change with SP configure.
You got to go to the GUI?
You can go to the GUI, or you can use an extended system store procedure.
Awesome. So what about the database level stuff, George?
Again, lots and lots of options on a per database basis. Now,
and let me guess, not all of them show up in the GUI.
Bravo. Give them a golf clap, everybody.
I'm sensing a pattern here.
Yeah, good observation. The options are categorized on a per database basis. Auto options, cursor options. You see some of the laundry list categories of options.
And how do we actually go through and change this stuff?
Well, like you said, with the graphical user interface, when in doubt, right-click and select to effect. I have to select the right object. So I'm going to right-click on the database in question, get properties, and then I'll go to options. Now, this is kind of startling when you first see this. I think there are an awful lot of options here, more than there ever have been, really.
Yep.
So like it has been pointed out, the GUI can't change every option. If I do want to change or have availability of any option, you'll see in code I'll use alter database, point to the name of the database, that's the DBX part, and then I'll often use the set statement or set keyword and then the name of the option and how I want to set that, like turning something on, turning something off, etc.
And you don't have to do a reconfigure statement or anything like that when you're doing an alter database, correct?
Good follow-up.
All right,
yep,
cool.
Excellent.
So let's go take a look at some of these. George is going to show us some of the ways that we can affect database properties in this next demo. George?
All righty, here we go.
All right. So what do we got going here, George?
All right, so next up, let's point to our appropriate database.
TinyDB. We're still playing with that one,
We're still going to play with the Tiny database.
All right.
And notice we've set this to offline. That's one of the availability options. I should have prefaced this, Rich. In particular, we're going to explore what we call availability options of databases. So when I use the offline option, the database, as you can see from my notes here, is absolutely inaccessible, cleanly shuts down the database without having to detach. The drama here, drum roll please.
Drum roll.
We see under databases, after a refresh, that there is a special icon assigned and a description.
Boy, I'll tell you what, I like that zoom because you can't see that icon at all without it, can
Yeah,
ya?
there you go. All right, that's a pet favorite tool of mine called ZoomIt. For anybody else that likes software tools, good job, Peanut Gallery. Microsoft actually acquired a super scary smart dude a while back. And I think ZoomIt is one of the tools that he contributed to the pile. But
okay, for a minute there, I thought you were talking about me, and I was wondering where that was going.
So now I'm going to set the database state to emergency.
Okay, so that's another availability option?
Another availability option. Limited access. Only sysadmins, plural, is the key, though.
Okay, so multiple sysadmins can hit it at the same time.
That's right. And so there are a couple of specific reasons why I might ever want to go to emergency, like a DBCC repair. We'll talk about this a little later. And also notice fancy little icon for emergency.
It turned red.
Yep.
I like that. So what's the next option we got?
This will turn us back into a normal production database by setting to online.
Okay.
Now another option or another state that you might need is read-only. Guess what read-only means?
Can't write.
That's right. You only can read. Now, can you think of a circumstance where something like read-only might be particularly valuable?
One of the things that you might want to do that for is on a reporting database where you want to ensure that data is not being affected by any users.
You had a good intent. I was thinking of being a mere mortal and committing a DB uh-oh.
Uh-oh.
Somehow,
what's a DB uh-oh, George?
A DB uh-oh is if a database inadvertently gets damaged and before anybody touches it further, you need to inspect it.
Yep.
So you can take it to a read-only state, notice again the fancy icon, and determine if and to what degree there might be damage to determine what you might do from there.
Awesome, awesome. Thanks very much, George.
All righty. Now, I could, I suppose, have a query that attempts to update the table. It's not going to work. Read-only really means read-only. The opposite of read-only, of course, means read-write, and notice it's gone back to its normal state.
Cool.
Another availability option is single user. So this allows, well, look what it says, only one authoritative user can connect to the database, and there's a reason that I might use that when I want to use a particular repair operation, which we'll look at later on. And if you like the other icons, Rich, let's see what you think about this.
Oh,
Get a little person there. And
they don't call it a GUI for nothing. Graphical it is.
All right.
Restricted user.
Restricted user, multi-user. So we have a bunch of different options, and now I'll set it back and put it in production. And
awesome.
That's it for that one.
Awesome. Thank you. So the next thing that we've got on our schedule, we're going to delve into a little bit of affinity and parallelism. George, what's that all about?
It has to do with workload, CPUs, allocation of resources to I/O activity, things like that.
Okay. And CPU affinity, I/O affinity, parallelism. We got a lot of stuff that we're going to talk about.
A lot of stuff to talk about. So Rich has volunteered to take on this topic. We'll take a look at parallelism defined, affinity defined, and then how we stick our hands in the metal moving machinery to change things that are not default settings and in what circumstances we might actually undertake that.
So CPU affinity basically is the process of telling the SQL Server in a multi-CPU environment, which CPUs are going to be involved in processing queries, in managing the database engine, and which ones are going to be excluded. Now, you might want to do that for a couple of reasons. You might want to do that because you have license restrictions. You've only purchased license for one or two CPUs, and you've got a 4 or 8 CPU box. Maybe there are multiple applications running on that CPU, things like that. I/O affinity is the same process. It's just a matter of allowing the CPU to be involved in the read-write process from the data files into memory and back again. Now, the default configuration for any SQL Server instance is for the database engine to make use of all CPUs and all CPU cores, which means that SQL Server really wants to have a dedicated box. When you want to change that, when you've got shared boxes, when you want to be able to control what the box is allocating its resources to. The default behavior is to allow Windows to manage all of those executions. When you set CPU affinity, there is a scheduler created for each CPU core, and it then manages the execution threads inside of the database engine. Now, there is one more consideration, and that's NUMA. NUMA is a hardware design where each CPU has its own dedicated memory and its own dedicated bus. Many manufacturers have different design considerations that need to be dealt with, so whenever you've got a NUMA machine, SQL Server does support NUMA processing, but the configuration that's appropriate really needs to be set up based on the hardware manufacturer. You need to talk to them.
Not everybody is great at knowing hardware intimately, and for those that might not know, NUMA stands for Non-Uniform Memory Access.
Thanks. I'm acronym challenged. I can never remember TLAs, ETLAs, or anything else. You know what an ETLA is, right?
I don't know what an ETLA is.
Okay, so TLA, everybody knows, is a 3-letter acronym. An ETLA, can you guess? It's an extended 3-letter acronym.
Awesome.
Okay. Back to something that's actually worth something now, parallelism. So, George, parallelism is the ability for SQL Server to utilize multiple processors in the execution of a single query. Not 3 or 4, but you asked a question that's spread out among 3 or 4 different data files on different drives. And it's a complex enough question where SQL Server thinks it might be more efficient to have multiple people working on it at the same time. It's like breaking down a software project into one developer doing everything or 4 developers working together. Which one's going to be quicker?
Sure, multiple.
Yeah, but is there any overhead involved when you got the multiple people?
Picture 4 people trying to paint a closet.
Oh, dear.
Yeah.
I would guess there's some coordination involved
there's
in
some
making sure.
coordination.
Yeah, so that's the overhead. And in SQL, it means that is the overhead involved in bringing the results from all the different ones back together. Now, there are a couple of settings available in SQL to control that parallelism. One is over and above the affinity. You can set max DOP for index, maximum.
Degree of parallelism.
Thank you very much. Again, my man with the acronyms, because I actually forgot what it was for a second. There's also a max DOP setting that you can put on an individual query if you want to override the setting for the database. So, last but not least, there is a cost threshold for parallelism, which is set initially at 0, which means that all queries are available to be parallelized. Doesn't mean that SQL will do it. But by setting that to a specific value, you then are controlling the complexity or the amount of resources that are being used before a query can be considered to be parallelized. Okay? To configure CPU affinity, there's alter server configuration. Also, you can right-click on the server itself and go to properties, go to processors, and it will allow you to check it off. George, can we go take a look at that one?
Can I show that?
Oh, I think so.
All right.
I think so. George wants to go play. Is that
right.
okay?
Let's go to properties.
Yep, that's okay.
All right. Well, wait a second. How come I can't select any of these checkboxes?
Uh-oh. Is that a problem?
It's not a problem. I just wonder why.
Could it be that this computer only has one CPU with one CPU core?
Yeah, well, it's real hard to allocate multiple processors and configure them if I only have one to begin with. So
Yeah.
you're seeing a good design of the user interface here.
There you go. There you go. And what about the I/O affinity, processor affinity? That's for both of them. Down, where is that max degree of parallelism? Yep, there's the checkboxes for CPU and I/O affinity. And,
Lead me.
All right. Cool.
All right.
All right. So let's move into our next topic here a little bit. And I particularly like this topic.
This is a pet favorite topic of mine as well. There's a chant that every database administrator should have, and that is automate, automate, automate. As we've talked about before, there are good reasons to automate. So in this particular section, we'll take a look at the automation subsystems that SQL Server has available. I don't consider that you've never heard of any of these features before, but I will say before you take your exam, you want to be solid on all these features. So we'll take a look at agent jobs and having scheduled workload in the background, automation steps. We'll also take a look at having automation security and the very highly configurable environment there. And then we'll look at the second major automation subsystem, which is the alerting subsystem.
All right. So what about these jobs, George?
Big picture here, you want to look at some of the moving parts of the automation subsystem. So I've tried to illustrate this briefly. Namely, I can have one or more jobs where a job is a collection of work that I want to run either ad hoc, on demand, or that I want scheduled.
All right.
So notice job one has one job step. A job step is the work that will get done within a job, and each job step necessarily is assigned a job subsystem.
Okay.
So you'll notice in job two that I could, for example, have more than one schedule. Maybe I have something that has to run at 10 in the morning and something that has to run at 8 at night. Well, there's not an even number of hours or a way to get both of those done unless I have a separate schedule. And what if job three is something that depends on when a vendor sends me a file, and that's unpredictable? I won't even have a schedule for that. I just run that ad hoc or on demand.
Okay.
Now, I'm sorry, the fun part is the reach. Who's the stretchy guy in Avengers?
I don't
Help me out
even
here.
know.
Mr. Fabulous, I think. Somebody in the chat will get me.
Mr. Fantastic.
Mr. Fantastic? Okay. So anyway, what's that? The Fantastic Four? Okay, I'll get straightened out. Boy,
Not a comic book geek, are you?
Am I going to get schwacked on the break time? Oh my gosh. So think about having a super long reach. That's really what the automation subsystem permits, because you'll see job step-wise, we have T-SQL subsystem, command exec, anything that's a batch file, an executable command file, PowerShell, amazing things you can do with PowerShell. Get a free ebook on PowerShell at PowerShell.com. I'm sorry, am I missing something? No. All right. Oh, thank you. I can run SSIS packages. So let's just assume all the automation real estate is covered. Anything I might want to do, I can get it covered. And then a final point is that I may want to become notified on the basis of when a job completes, and or if it fails. So lots of moving parts there.
Now, a lot of times jobs go out and they have to actually access resources either in the database or in other parts of the network or on the computer. How do we manage that whole process and make sure that they don't do anything inappropriate, shall we say?
Sure. We want to make sure they don't do anything appropriate and that those accounts are not compromised. Well, when it comes to setting up automation security, there are two major divisions. The T-SQL job subsystem is treated sort of unto itself. And the security of a particular job step that is configurable, security on a per job step basis, has to do with ownership. So job owned by sysadmin versus a job owned by a non-sysadmin. And we'll see that other job steps have they have a different security mechanism. And that is dictated by, again, whether it's a sysadmin-owned job or a job not owned by sysadmin. Rather than go through the painful detail of seeing this on the slide, or running through all the detail on the slide, this is more of a reference.
And how can we provide an identity for those steps to use, per se?
Yeah, so the SQL agent, if I could go back for just a sec, the SQL agent has an account that it must run under. We saw that in the earlier module. So picture, for example, a diameter, a circle with a diameter, which represents maybe an amount of privilege. Now, for every job and every job step, with this rule book, that will dictate how jobs and job steps will run. We'll find then I might need to change that diameter to have generally larger privileges, but just for a moment.
Yep.
So I can use execute as for T-SQL job steps, but as we move into the next topic, we'll see that for other job steps, we have something else. I'm going to move over to my virtual machine for just a moment to reveal something. So if you guys would flip me over. All right. So I'm looking at the SQL Server agent, and I see a very long laundry list of available proxies. Now, here's the relevance. Let's say I happen to have a job, and it doesn't matter what job I have right now. I'm going to open up properties of the job.
Okay.
I'm then going to go to steps of the job, and when I edit the properties of the job, notice I could configure run as. Now, run as actually says point to a proxy. And the only one run as is not available for is a T-SQL agent step. This is where I would use execute as in the T-SQL code, so I can get the same thing done, I just have a different mechanism.
Got it.
So looking for a moment.
What is a proxy then?
Yeah, so a proxy is really an alternate identity. And if you guys would flip me back to the slides now for a sec. You're going to have to follow me deep down the rabbit hole for a second here.
Uh-oh.
So what I need is an alternate identity that's able to do something. So I set up a Windows account, and I assign that account privileges, the privileges I need a job step to have.
Okay.
Then I have to create an instance level object, a credential object. Looking at the chain of events here, a credential necessarily points to a Windows account.
Okay.
Then I create an agent proxy, and an agent proxy necessarily points to a credential. And then finally, on a job step by job step basis, I can point to a proxy, which then will, well, enlarge the diameter of whatever capability I need for that particular job step.
Awesome. Now, is that the only security that's involved in SQL Agent?
Think, Rich, of a really busy server. Maybe I have a couple hundred databases on a machine. We'll learn more and more about maintenance, where I might have 4 or 5 jobs just for a single database. Multiply that by 100 or 200 databases. I could easily have a couple hundred jobs on a heavy workload machine.
Okay.
So now I'm at a fork in the road. If I'm the system administrator of that instance, I might need some help. So do I want to raise someone all the way to sysadmin to give them entire privileges over the job administration system or not?
I wouldn't.
And if I don't want to take that approach, I have a job delegation strategy that I can use. Now, over at the right, you'll find a curious laundry list of database roles specific to the MSDB. And where I've highlighted, notice that there are the SQL agent family of roles, and specifically there are 3. If you're up for the gory detail, I have a hyperlink here where you can see exactly what each role can and cannot do, and the roles are in increasing privilege. So we have the agent user role. It can manage basically what it owns. The reader role can do anything that the user role can, and some additional stuff like at least get information on multi-server jobs, properties, schedules, so it can look at everything even beyond what it owns.
Okay.
Of course, the SQL agent operator can touch and change more than that. And then the next up on the proverbial food chain would be a sysadmin.
So I got to ask you a question, George. Over in that little box on the next to where it's showing the instance, I don't see SQL agent in there. How come?
I was hoping you'd ask about that.
I kind of thought so. That's why it's on the slide, right?
Yeah. So why would the agent not show up there? If someone is not a member of either sysadmin or one of those roles, the agent node doesn't even appear in Management Studio.
So if they're not going to be able to play with it, they ain't even going to be able to see it.
That's right.
I like that.
I do
like
too.
that. So can we go take a look at some of these operators?
That's
and
right.
Jobs and job steps and all that good stuff. How do we set up that automation?
Alrighty. So one of the first things that you'll do in setting up the automation system is setting up an operator. They're going to be, guys, would you go ahead and flip me to my virtual machine? Thanks. So one of the first things I'd want to do is set up an operator. They're going to be the destination notification of job outcome. So we'll take a look, and I will tell you, every bit of this can be configured in code. And we'll see kind of in this demo a mixture of some code and also GUI-based demonstrations. So let's say we call this this operator the DBA team. I'm big on having plural names here. General rule of thumb: the work stays the same, the worker may change.
Okay.
So let's just leave kind of a general name here, and for aliasing purposes, we could have something like, what do you call that, a distribution list. So let's say...
So the operator is not a user, the operator is a message destination.
That's right.
Awesome.
Yep, and so I can go ahead and apply the hours of availability for this operator. This becomes important in the circumstance when a notification message is sent. I should have a little fun with this and set 24/7 hours, but I won't bother to do that right now.
Oh, why not? That's the real world. Have you
Yeah.
ever met a DBA that doesn't work 24/7?
Yeah, so now I have my operator here, and subsequent to that, I'll go ahead and create a job.
Okay.
So let's call this Backup System Databases.
Okay.
So that'll be the name of our job, and now I want to set up the job steps. I need to pinch a little bit of code here, Rich.
Like every good DBA, you pre-wrote your scripts.
That I did.
I like that.
I'll go for double bonus if they even entirely work. And of course I have my taskbar up top, which I forgot about, and auto hidden. So there's my new job. So next up, I'm going to create a new job step, and we'll call this, after I paste in my code, Backup Master. For brevity, I'll just say Backup Master. You're going to have better titles. You've noticed that I have a lot of cheeky rules of thumb, and one of my other rules of thumb is leave a trail.
Oh, yeah.
I like documentation. I like being obvious. So,
Self-documenting is a very good thing. You should practice it in all of your naming conventions on everything.
there we go. So we'll find that job steps actually have a humble, did I say humble?
You did.
A humble workflow capability. And lots of configurable options with a job step. Of course, it'd never be within the realm of possibility for one of my coworkers to RDP in the middle of the night, reboot a server when there's some automation that's supposed to occur. So I can have retry attempts, retry interval, some basic things like that. Now, after that job step, I'm quickly going to make two new job steps. Let's say backup MSDB.
Yep.
One more.
Let me guess. Backup model.
Backup model.
Well, those are the system databases you need to back up, so that works.
That's right. Now, this last time around, instead of going to the next step, I want to quit the job reporting success.
Okay.
I'll click on OK and a schedule.
All right.
So I would pick a schedule. Let's just say we want this to occur every single day rather than particular days.
Okay.
And maybe we want this to occur at 2 a.m.
All right.
We'll say, give a schedule name nightly at 2 a.m. The final part is setting a target for notification. And notice the configurability here. The operator that I have can be notified when the job succeeds, also notified, same operator, when the job fails, or just when it gives its best effort when it completes, whether it finishes successfully or not. Now, just for drama value, let's see if this dog will bark. We'll go ahead and start it. See if I put in my code right.
Uh-oh.
Okay. Kaboom. So this is where I could use troubleshooting facilities, go ahead and view history, and find out what it was that actually went wrong. All right. So we could drill down, notice, on a step by, well, actually job outcome status, and then step by step. All right, awesome.
Awesome. So is there anything else you can do in Agent that might be useful?
Wow, lots of stuff. So we have all kinds of other subsystems. Were you referring to the other subsystems that we have?
Yeah, I was thinking more along the lines of letting the agent tell you when something happens.
Ah, yes, alerts. I'd like to, let me get a quick look here. Yeah, I'd like to equate the alerting subsystem to a tripwire.
Okay.
So let's say I had something on double secret probation in my property, and I wanted to be made aware if somebody crosses into my property and I didn't want them there.
Okay.
I compare this to SQL Server. I can set up a listening ear to listen for particular circumstances, and should they occur, knee-jerk reaction, I want SQL Server to do something about it.
Awesome.
Now, for your benefit, I have the basic alerting architecture here, and I think what I'd like to do is just show you how I configure an alert. Before you flip the slide, notice that I have three, in the light blue area, three key areas that I can use as the basis for setting up the tripwire. So let's go over to my virtual machine now and show some of these.
All right, so the performance condition alerts, we can do an event alert, we can do a WMI, which is Windows Management Instrumentation.
That's right. Now, the first thing that I'm going to do is add a couple of custom error messages. Don't laugh at my messages here. That's just purely for humor. And you'll notice the way that I add a custom error message is with SP_add_message. These are instance level objects. Now, a clever thing is that these could actually be called by stored procedures through the raise error statement. But for right now, let's just make a mental note that we have an error message we might specifically be concerned about, 5649. All right, so just so you know, you can query sys messages if you wanted to see those custom message IDs. All of them, by the way, have to have an ID over 50,000. Okay, so now to set up my alert, I'm going to go to Object Explorer. When in doubt,
select it first.
That's right. Right click, and now we'll say error alert. Of course, I'd give probably a better description here. Notice one of the key things is that I may want to set up an alert that I'm not ready to enable.
Okay.
So that's a troubleshooting thing. Make sure that that the alert is enabled. So now I have the alert condition, and I want you to observe how the form changes when I pick a different major area of tripwire, as I described. We'll use an event alert. The next major thing that we have to determine is, will this apply to all databases or just a particular database?
So we can set up instance level alerts or database level
That's right.
alerts. Cool.
And then alert errors, or errors I should say, all are categorized according to a severity. Or I could say that there's a particular error message number that I'm concerned about. Do you remember that number off the top of your head?
I do not.
Of course, I should have copied it. So we will this time. There, how's that?
There we go.
All right, so the big deal here is, what do I want to do about this? So one of the things I might want to do is execute a job. Now, I just picked this one that I made.
Yep.
That shows that you can pick a job, and or, notice the user interface here. Pink highlighting for the ladies this time. Notice that I can pick all of my standard notification methods, email, pager, etc., etc.
Awesome. So just out of curiosity, if you do set up an error alert, where does the agent monitor for those errors?
Excellent. So now what we'd find is that I would go to